Hi everybody, today we're going to look at section 1.3, which is on problem solving. And our goal with this section is to really just show you a bunch of different strategies on how to problem solve. Not that there's one specific one that will always work, but just some different ones that you can try and have kind of in your wheelhouse to use when you come across different problems. So first, you have just some general guidelines on what to do with problem solving. I know it can be a tricky subject for most people, so you'd really just want to keep at it and really keep practicing and trying. So once we go through a few examples, hopefully you can use those to help guide you in other examples and use some of the tools that we've discussed, or we are going to discuss in these videos. So the first thing you want to do is always understand the problem. Maybe this seems silly, but it's actually a really important step. So you want to read the problem really several times. So a lot of times students will just kind of skim through 1 or 2 times and they think that's sufficient, but you really need to read it 5 or 6 times to understand the problem if it's more complicated. So the first reading can just be kind of a quick overview to kind of see what to expect. And then the second reading, or the third or fourth, however many it takes you, write down some information that you are given that you think is important, or you could underline that information or highlight it, whatever helps you to kind of focus in on the problem. The other thing I like to do too in this section is to think about your question that you're being asked. So maybe underline that question, or often what I like to do is I'll write down the goal and I'll use that question to find my goal. So I'll say to myself, oh, find this, right? And again, it seems kind of silly to maybe write that goal out, but it really only takes a few seconds and it just helps me narrow down. If I have a big paragraph of information, just seeing my goal reminds me, okay, this is what I need to figure out. Once you know what you need to figure out, then you got to come up with a plan. So there's a ton of different ways to problem solve. In this section, you're more than welcome to use any technique that you like. So there's different ways and sometimes multiple ways to solve the same problem. So you could use inductive reasoning to look for a pattern. You could make a table or a list. You could use estimation to make an educated guess at the solution, right? Check the guess against the problem's conditions and work backwards to eventually determine the solution. So maybe kind of guess at a starting point and tweak from there to find the exact answer. Try expressing the problem more simply and solve a simpler styled problem. So one thing I like to do there, and this is actually related to another bullet point, is if the problem seems overly complicated, try changing the scenario or changing the units. So if I'm dealing with a problem that I'm not as comfortable with, maybe it's in a field that I'm not comfortable with, try changing it to something you are comfortable with and see if that helps you figure out the strategy. You can use trial and error. You can list the information in a chart or a table. You can make a sketch or a diagram. So those are great. I love making pictures if I can. Relate the problem to something that you've already seen before. So if you've seen a similar style problem in this video, let's say when you're doing your homework, go back to this video, go back to your notes, see if you can figure it out. Or maybe it's a different topic, but you're like, oh, I've seen that before. I know I've done that, even though it was this topic, not this topic, right? So you can use what you already know. Look for a catch if the answer seems too obvious. Sometimes I feel like that's most important with percents. A lot of times with percent examples, we tend to just jump in and always take that percent and multiply it by another number and think that's the answer. But that's not always the case. So be careful, read through carefully, make sure you understand your information, and make sure that there's not some trick or something that you missed. Or sometimes there's extra information in a problem. So maybe they gave you extra information that you don't need. Use the given information to limit possibilities, and of course, use common sense, right? If you get an answer, let's say like -30, but you were asked to find the dimensions of a swimming pool, that doesn't make sense, right? A negative number. If you were asked to find a temperature, well, -30 could make sense, right? If it was very cold. Carry out your plan, solve the problem, and then look back and check the answer. So the answer should satisfy the conditions of the problem. So it should actually answer the question, right? Make sure you've answered the question. And it should make sense and be reasonable. So like I said, if you're getting answers or your strategy involves something that doesn't seem reasonable, doesn't make sense, then go back and try again. All right, so let's just start with an example here. So which necessary piece of information is missing and prevents you from solving the following problem? So instead of jumping right in to solve some questions, we're going to try some kind of mini problems first to start. So this one asks you to read through as if you were going to solve the problem, but figure out what's missing. So a man purchased 5 shirts, each at the same discounted price. We want to answer the question, how much did he pay for them? So there's my question. That's my goal, right? Goal is find out how much he paid. So we're going to find his cost. But I don't have enough information here. I know he bought 5 shirts, and I know they were all the same price, but no one's told me how much they were. So that's the information that I'm missing, is I do not know. So do not know the price per shirt. Or on the other hand, if I had the total price, I could divide by 5 to get the price per shirt, right? So I need something. I need some sort of price here. I need that price per shirt, ideally, or if I had the total, I could work backwards if I needed to, and then use that total to find the price per shirt. But I have nothing, so I cannot answer this question. All right, so now that we've done that, let's look at some examples. And I'm going to go through each of these examples, let's see, for you guys. All right, but it's good to try them on your own too. So at any point during the video, feel free to pause it and give one of these problems you're trying on your own, see if you can do it. So in the following problem, one more piece of information is given that is necessary for solving the problem. So they're telling us that we have extra information here. Identify the unnecessary piece of information and also solve the problem. So I think you can really do these in either order. We're kind of doing the whole thing together. So we are going to solve the problem, but if we notice we're not using a piece of information, then it could be extra. So a roll of easy white paper towels contains 100 sheets. So, I'm going to make a little list here of easy wipes. And I see 100 sheets per roll. And I see that it costs $1.38. Another brand, Quick Clean, so Quick Clean, contains 5 dozen sheets per roll. And costs only $1.23. If we need 3 rolls of paper towels, not towers, which brand is the better value? So if we're asking which brand is the better value, that's our question, right? So our goal here is to find which brand is cheaper, right? So if we want to find the better value, we're actually asking, well, which one's cheaper? What's going to be more bang for our buck, so to say, right? So we get more for our dollar. So we need to figure that out. So first thing, I see that I have 100 sheets here for 138, and I have 5 dozen sheets here for 123. Well, what is 5 dozen? So a dozen is 12. So if you see the term dozen, then that's 12. So we're going to do 12 times 5, which is 60 sheets per roll. Now, I do want to clarify, if you see a baker's dozen, that actually is 13. But if you just see the word dozen, it's always 12. So just be careful. If you ever see a problem that says a baker's dozen, then that means 13. Because theoretically, a baker would make 1 extra just in case something got burned or came out bad. All right, so what we're going to do here, and you may have seen this before, or if you haven't, that's okay. We're going to use something called the unit price to figure out the better value. And a unit price allows us to compare things, compare their price at the same number of units. So for instance, this one has 100 sheets and this one has 60 sheets. So if I knew how much one sheet cost in each of them, then I'd be able to see which one was actually the better value, right? Is 100 sheets at 138, which is more expensive, better than 60 sheets at 123? I don't really know. So how do we find the unit price? So what you're going to do is you set it up like this. You take the price and you divide it by the number of units. And then we're actually going to divide that out. So you're going to go ahead and do the division. So for easy wipes, the price is $1.38, and I have 100 sheets. Now, dividing by 100, we can actually do without a calculator. We're going to take that decimal and move it 2 spots to the left. But if you don't remember that, just take out your calculator and you can do that. So it becomes 0.0138. And when we do that, it becomes per sheet. So per one sheet, because we're dividing this out, so that denominator is going away, it's becoming 1. So the cost here is about 1 cent per sheet, a little over. All right, let's see what happens for Quickie Clean. So their cost is $1.23, and we get 60 sheets per roll. Now, this is not one that I can do at home. So, sorry, I'm going to grab my calculator. All right. So here's my calculator. I just have an app on my phone, and I'm going to take that $1.23 and divide it by 60. And I get 0.0205. And again, once we do that division, that's per one item. So in this case, one sheet. So which one is cheaper, right? The cheaper one, this one is about 1 cent. This one is about 2 cents. This one is cheaper. So Easy Wipes is the better deal. Now, the extra piece of information here was that we were going to buy 3 rolls. So we're going to buy 3 rolls no matter what. What if I'm trying to find the better value? So value overall doesn't mean the cheapest in that moment, right? So the cheapest in that moment is to just buy 3 rolls of that Quick Clean paper towel, right? But realistically, that Quick Clean paper towel is almost twice as much as that Easy Wipe when you break it down per sheet, because it has much fewer sheets. So the better value here will be the Easy Wipes. So even though it's a little bit more for that roll, it's going to last me much longer and be the better cost over time. Now, this idea of unit price you can use when you go shopping, and I do it all the time. So as a quick tip, if you're ever out shopping at the market and you're trying to compare different sizes or different brands. So let's say you're buying Cheerios and they have the family size box and they have like the smaller box, and you're like, well, which one is really better for more for my buck, right? Which one's the better deal? Next to the price on like the racks, they'll usually have another price that's often in a different color, like in an orange box or a green box or a yellow box. That is your unit price. And that allows you to compare items of different sizes. So it will tell you the unit price for the big box of Cheerios and for the medium box of Cheerios. And the one that's cheaper for the unit price is actually your better deal overall. So it does this calculation for you. And I do that all the time. Sometimes the bigger box isn't always cheaper. A lot of times it is, but not always. Or they could be very comparable. So you may say to yourself, well, I don't really need a big box. Let me just get the small box because they're about the same price, right? So there's other things that you take into account too when you shop, but that unit price is really helpful. So take a look for it next time you go out shopping, see if you can see it. All right, let's do one more in this video and then we'll pause and we'll do some more in the next video. By paying $100 cash upfront and the balance at $20 per week, how long will it take to pay for a bicycle that costs $680? So again, there's different ways that you can do this. One way you can do it is with a table to kind of look at $20 per week and see what happens there. Another way is to think about it a bit more algebraically. So if you're kind of good with algebra, you may think about an equation or something like that. And so whatever works for you. So I notice my total cost is $680. And if we pay $100 cash upfront, that means you're going to give them $100 today. So that $100 gets automatically subtracted out. And you still owe the store or the company or the credit card, whatever you're doing, $580. Now you're going to pay it off $20 per week. So again, one strategy you could use here is to take that $580 and subtract $20 each week. So after the first week, you would have $560. And then next you have $560 and you're subtracting another $20. So now you only owe 540. Oops, 540. And then you subtract another 20, and then you owe 520. And then in week 4, you pay another $20 and you owe 500, and so on. So we can make a table for 1 week at a time and just subtract that $20 and see what happens. So that's one way to do it. Another way to do this problem is to recognize a pattern, right? So we're subtracting 20 each time. So maybe you're able to kind of group it together or do it a little more quickly when you realize once you get down to another 100, like how fast that's coming off. And you may also recognize, I hope, that repeated subtraction also is division. So when you're repeating subtraction over and over again, you're actually performing division, just like repeated addition becomes multiplication. So another way to do it, a quicker way, but it's okay if you don't recognize this, is to take that 580 and divide it by your $20. So when I do that, I have my 580. I divide it by my 20, and I see the answer is 29. So it's going to take me 29 weeks to get this paid off. So it will take to pay that bicycle off. So again, just there's different strategies that work for different examples. And you can really use either one, right? So it doesn't matter which example you use or which strategy you use, as long as you get there, you get there. So if you notice that you can subtract 20 each time and make yourself a table and kind of follow that pattern, that's fine. If you recognize that, oh, I'm subtracting repeatedly, that's really just like division, then you could do it that way too. Both are great ways to solve, and you'll get to the same answer.